Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
So this direct memory SS, it is also known as the DMA controller, and its IC is 8257. Now this controller, it is designed by the Intel to transfer the data between the microprocessor or the central processing unit and the peripheral devices. So this DMA controller, it is designed to transfer the data at fastest rate, and it allows to transfer the data without subjecting the processor a heavy overhead. Let's take an example so that you can easily understand it. Suppose we have the microprocessor here. I'm writing MPU, and this microprocessor, it is communicating with the peripheral device. Peripheral device, it is the input output device, so we can write here a peripheral or input output device. Now when the microprocessor, it communicates with the peripheral or input output device, it will either transfer the data or it will either receive the data from or to the peripheral or input output device. So the transfer of data takes place between the microprocessor and peripheral. Now this data, it is stored in the memory of the microprocessor. So it is basically interacting with the memory of microprocessor. Suppose the microprocessor, it wants to transfer a large amount of data which is in bulk, and every data it has to transfer to the input output device. Okay, and input output device, if also it want to send some large amount of data to the microprocessor, then also it has to send a bit by bit to the microprocessor. So it will take a large amount of time will be taken. Okay, so much time will be taken, and for that time the memory of the microprocessor will be indulged in this transfer of data. So the microprocessor will get busy in this transfer of data task, and it cannot perform any other task in between. So to relieve the microprocessor from this task that it get busy in the transferring of data, we can use the DMA controller here. So the DMA controller, it will be connected between the microprocessor and the peripheral device, and this DMA controller, it will transfer the data at a fast speed and without subjecting the processor a heavy overhead. So the processor will not be busy in the transferring of data, and the DMA, it is going to perform the transfer of data between the peripherals and the microprocessor. Now how this DMA, it will transfer the data, it will get the control of the microprocessor buses like control bus, address bus and the data bus. All the buses will be in control of this DMA controller. That is why its name is DMA controller, direct memory access. Direct memory access because it can directly access the memory of the microprocessor, and it is controlling the buses of the microprocessor. That is why its name is direct memory access controller. So this DMA controller, it is controlling the buses and the memory of the microprocessor, and through the control of the buses and memory, it can transfer the data between microprocessor and peripheral, and the microprocessor will be free from this task and it can perform other tasks which are of high priority than it. Okay. So this is the use of the DMA controller. So as I have said that using the DMA controller, the device requires the CPU to hold its data, address and control bus so that the device is free to transfer the data directly to and from the memory. Okay, so here in this diagram we have that using this DMA controller, the device, it is going to request the microprocessor CPU that it hold its data and control and address buses to the DMA. That means it relieves its control and give that control to the DMA controller, so that using these buses, the data, address and the control buses and the access of the memory, by accessing the memory of the microprocessor, it can transfer the data between the input output device and the processor. Okay. Now, what's the need of this DMA controller? I have said that this DMA controller, it is transferring the data at a fastest speed between the microprocessor and the input-output device. So, whenever in the high-performance embedded system, wherever we need to transfer large chunks of data, then we can use this DMA controller. So, the need of DMA controller comes wherever the large amount of data has to be transferred from one device to another device. Now, this DMA, it is transferring the data by having the control of the buses of the processor. So, how this DMA controller, it is getting the control? The data transfer, it is initiated by having the hold and the HLDA signals. There are two signals in the DMA which are known as hold and HLDA. So these two signals are used by the DMA to get the control of the buses of the CPU. So it is using hold and HLDA to get the control of buses. So now let's study the features of this DMA controller 8257. The IC for the DMA controller, it is the 8257. Now its first feature is that it has 4 channels which are acting as which are connected to the 4 input output devices, because we know that DMA controller, it is connected between the input output device and the microprocessor. So this DMA device, it is having 4 channels which can be connected to 4 input output devices. So 4 input output devices can be connected to the DMA. So we can say that 4 input output devices can simultaneously transfer the data to the microprocessor. Now next feature is that each channel, it has a 16-bit address and 14-bit counter associated with it. So there are 4 channels. So each channel will have a 16-bit address and a 14-bit counter with it. Okay. So 4 channels are 0, 1, 1, 2 and 3. The 4 channels are there. So each channel will have a 16-bit address through which that channel will be selected, and 14-bit counter is there, okay, which is going to transfer the data. Now each channel, it can transfer the data up to 64 kilobytes. So there is a large capacity of data transfer by the channels of DMA. So each channel can transfer up to 64 kilobytes, and it has 4 channels, so it can transfer 4 into 64 KB of data through the DMA can be transferred. Now each channel of the DMA, it can be programmed independently, because these we have to write the instructions in the channels that which channel is to be used for the data transfer, and in which mode the channel will work, how the data will be transferred. So all this is decided by the modes of the DMA controller. Now these modes, they are decided by the control word which is written in the control register. So we can say that each channel which is working in different mode, it is independent of each other. It will not have any effect. Suppose like first channel, it is working in mode 0, and second channel, it is working in some different mode. So the working of each of the channel, or programming of each of the channel, it is independent of each other. Now each channel of the DMA, it can perform the read transfer, write transfer and verify transfer operations. These are the 3 operations which are related with the transfer of data, because whenever the data is to be transferred, first the data has to be read by the DMA, that this data is to be transferred. Then that the data, it is to be written into the memory of the microprocessor if it is transferred from input output device to the memory, and if it is transferred from memory to the input output device, then at both the times that data has to be written into the device. And the last is the verify transfer, that the data has been completely transferred and it is correctly transferred by the DMA. So these are the 3 operations which are related with the transfer of data: read transfer, write transfer and verify transfer. So each channel of the DMA, it can perform the 3 operations independently with each other. Now the DMA controller, it generates a special signal which is called the mark signal, and this signal indicates that the 128 bytes of data has been transferred to the peripheral device. So this is a signal which is generated by the DMA, and it is sent to the peripheral device to say that the 128 bytes of data has been transferred by it. The DMA controller, it requires a single phase clock, and its frequency range is from 250 Hz to 3 MHz. Now the DMA controller, it operates in two modes which are known as the master mode and the slave mode. These are the two modes in which the DMA operates. So in the master mode, the control of the buses is with the DMA, and DMA is going to transfer the data from the microprocessor to the input output device or vice versa. Means the control of the buses of the microprocessor are with the DMA. Okay, so DMA is controlling the data transfer basically, and it's the master. That is why this mode is known as the master mode. Now the second mode is the slave mode. Now in the slave mode, the control of buses is with the microprocessor, and microprocessor is going to send the status of the registers, and it is going to send the control word to the DMA. So DMA, it is acting as a slave to the microprocessor. So first is the master mode, in which the DMA is having the control of the buses of microprocessor, and in the slave mode it is acting as a slave to the microprocessor, and microprocessor is going to send the data to the DMA controller. Okay, so these are the features of the DMA controller. Now let's see that how the DMA controller it works. So initially, when any device it wants to sense the data between the device and the memory, the device has to send DMA request to the DMA controller. So first, when the data transfer takes place, if the device, suppose it's a device, peripheral device, which wants to send the data to the memory of the microprocessor, and in between the DMA is connected. So here we have the memory of microprocessor. Now when any device has to send data between the device and the memory, the device has to send DMA request to the DMA controller. So this device is going to send a request which is represented as DRQ and known as DMA request to the DMA controller, that it wants to send some data to the memory. So this is the first step. Now when this device has sent the DMA request to the DMA controller, then in response to this, the DMA controller, it is going to send hold request to the CPU, and it will wait for the CPU to assert the HLDA signal. So DMA, it is going to send a signal which is known as hold request, that is HRQ, to the central processing unit. Now the central processing unit, when it will get this request, it means that the DMA wants the control of the buses of the central processing unit. It wants that it is sending the request of the device, that this device wants to send the data to the memory. It is acting as an intermediate between the two components, that this device wants to send data to CPU. So first it is requesting the DMA controller, and this DMA, it is sending the request to CPU that I want the control of your buses so that the data can be transferred to the device. Now in response to this, the CPU will send the signal HLDA, which is hold acknowledge. Now this signal when the DMA gets this signal, it means that CPU, it is allowing the DMA to have the control of its buses and send the data from the memory to the device. Okay. Now when this CPU, it has generated the signal HLDA, means it has acknowledged the hold request. So this CPU, it is going to now leave the control of the buses to the DMA, and it is going to tri-state all the data bus, address bus and the control bus. So now the control of buses will be with the DMA controller. So the CPU is going to leave the control over the buses, and it will acknowledge the hold request through the HLDA hold acknowledge signal. So now the control of buses is with the DMA controller, and now DMA is going to transfer the data between the memory and the input output device. So now the CPU, it is in the hold state because all the buses, they are under the control of DMA. So now the microprocessor, it can perform any other function, and the task of data transfer will be performed by the DMA. And DMA, it will manage the operations over the buses between the CPU, memory and the input output devices. So in this way, the DMA, it works and it transfers the data between the device and the central processing unit. So in this video, we have studied about the DMA controller, which is the direct memory access controller, and its IC is 8257. We saw some of the features of 8257, and then we studied the working of the DMA controller. So I hope that this topic is clear to you. Thank you.